So one way we can kind of look at what is the overall sort of total market for solar power, and this chart's kind of very busy, but what it's actually showing here is this is basically a distribution curve. This is a statistical bell curve. So if we take all of the kilowatt hours, all of the billions and billions of kilowatt hours sold in the United States, and we plot them out by how much they cost and how many of them are sold, we get a curve much like this. And actually, if you look closely, it's actually broken down into the three sort of main three sectors of the electric industry: industrial, commercial, and residential. And it's kind of roughly a three-way split in terms of how much energy is sold to those three sectors. And of course, we notice that the solid gray line for industrial power, the costs there are cheaper. So the average value for industrial electricity is about 6 or 7 cents per kilowatt hour. If you look at the commercial sector, it's a little bit higher. The average rate for electricity is between 9 and 10 cents per kilowatt hour. At residential, the cost per kilowatt hour is more. The average rate for electricity is about 11 to 12 cents per kilowatt hour across the United States. And so the characteristic that all of these curves have in common is the fact that they all have kind of this long tail off to the right. So the reason for that long tail basically is that there's a lot of reasons that electricity can cost more, but not a lot of reasons why electricity can cost less. So down at sort of the left end of this curve, we see that very little electricity is sold for, say, 3 or 4 cents per kilowatt hour. Generally only at the industrial scale, and that's a small minority. You know, most is sold for more than that. And some electricity is sold for quite a bit more than that. And that's, you know, different regions, different areas of the grid, different customers may, for whatever reason, find themselves paying a lot for electricity. So in some parts of the country, paying 15, 16, 20 cents per kilowatt hour is not unheard of. Certainly in places in California and places in the Northeast Coast, electricity for all users, residential and commercial, can get very expensive. And that's sort of represented over here. So there's this small market of very expensive electricity. And historically, that's kind of the only electricity that solar has been able to compete with in an unsubsidized marketplace. And so we can kind of, in our next slide, what we're looking at here is if we look at various installation costs for electricity. So when we're talking about PV costs, there's two ways to talk about the cost of solar. One is the cost for the installation, which we typically break down in dollars per watt installed. The other is what we call the LCOE, or the levelized cost of electricity, and we'll be diving into the LCOE metric and what goes into creating it throughout the course. But what I did here was I calculated some sort of benchmark install prices and some average levelized cost of that electricity. So if we look at the cost of the solar installed, look at its usable lifespan, the costs that go into maintaining it, things like that, we'll come up with, you know, what is the cost of that solar electricity on a per kilowatt hour basis. So going back 5 years or so to 2009, solar was, you know, $6 to $7 per watt installed. So even if you get a good price on solar, maybe $6 per watt, if you actually did the math and you factored everything in, assuming, you know, this is again an unsubsidized case, we see that solar electricity cost about 23 cents per kilowatt hour, and that's sky high, and obviously that's well above and beyond what most electricity costs. But it is competitive with a very small sliver of the electricity market. If you fast forward a few years, now looking at 2013, last year, and we'll see some numbers on this, you might find an installation price in 2013 of $4 per watt. So we saw a significant reduction in the cost between 2009 and 2013. And the levelized cost of energy fell from about 23 to maybe 18 cents per kilowatt hour because of that. So a significant reduction, but it still leaves us pretty expensive. So that really significant reduction in price that we saw, all that really did was move us from being competitive with this much electricity to now being competitive with just this much electricity. So for the past few years, these big reductions in cost of solar have really just served to kind of move us down this long, skinny tail. So big reductions in price have only left solar sort of only marginally more competitive with a little bit more energy out there being sold on the grid. But from this point forward, this is where things get really exciting. Because now if we look at 2013 versus some of the projections for cost reductions going over 2014 to 2015, let's imagine now that solar gets down to around $3 per watt installed. Well, now it has a levelized cost of energy of about 14 cents per kilowatt hour. And again, that's unsubsidized, not assuming any tax credits or anything at work. And that's actually competitive with a significant chunk of the energy marketplace. So you look at the size of that red bar. The amount of power being sold at 14 cents per kilowatt hour is much greater than the amount of power being sold at 18 cents per kilowatt hour. So it's competitive with that electricity as well as sort of everything behind it on that long tail. And then potentially moving beyond that. So I put here what's called the Sunshot Program, which is a Department of Energy initiative aimed at driving down the cost of installed solar power. They have a goal of getting residential solar power down to just $2 per watt installed. We'll be speaking more on how that's going to be achieved and when that might happen. But if we do get there, that means solar electricity is only going to cost about 9 cents per kilowatt hour. And what we notice is that implies huge upward trajectory in the market share here. So a lot of the country's electricity is being sold at around 9 cents per kilowatt hour or more. And solar at that price is going to be competitive with it. So the kind of the key takeaway here is that currently, and again, we were just looking at some unsubsidized numbers. So what our tax credits and rebates have been doing for us right now is sort of artificially moving us along that curve by defraying the upfront cost of solar through rebates or tax credits for solar. That makes it effectively cheaper for the end user. That makes the effective levelized cost of energy lower. So that's been sort of pushing us along the adoption curve. And those initial reductions in PV costs from, say, $7 per watt to $5 per watt, really only marginally increase the market. It's the next reductions in costs that we're going to see kind of from this point forward that are really going to cause the market to explode kind of wide open. Because now if we kind of going back to look at it, as we go up, we're getting now into kind of the meaty part of that curve. So relatively incremental reductions in the installation cost as we kind of move down that cost curve give us these ever increasing chunks of the electricity market that solar is now competitive with and is at grid parity with. So this is why you see a lot of those banks and forecasting groups projecting some very healthy, serious growth for solar over the next 5 years or so. For this reason, that we're entering into a phase right now where grid parity is going to start expanding rapidly. So right now we've only seen it in a few places like California and Hawaii, but it's going to be expanding throughout a lot of the country very rapidly and very quickly.